Hello, students. Okay, so this is limits day 5. Today we get to do limits involving trig functions.
Yay.
Yes.
Wait, why are you recording?
Because I'm not going to be here this afternoon.
Oh, cool. You're recording.
So we're recording it for 5th and 6th hour. Yes, this is in front of 1st hour, and they're going to be on their best behavior.
And then you're us?
Probably.
Yo, shout out to our muscle.
Okay. So this is on limits involving trig. And basically we have 3 formulas that we're going to be using throughout this lesson. And so we'll just kind of manipulate these formulas to get our answers. So the first one is the limit as x goes to 0 of sine x over x. And that equals 1. Oops, over x. So if you actually plugged in a 0 there, the sine of 0 is 0. So you'd have 0 over 0, which obviously means to investigate further. But this sine x over x is not something that you could like factor or simplify. But if you look at the graph will actually, at 0, it actually does approach 1. So that means there's a hole at 1, but it's not something that we can just easily simplify. So that's why we kind of use these rules or these properties as we're working out problems. The next one is that the limit as x approaches 0 of sine kx over x. So maybe it's sine 2x or sine 3x. That always is going to equal k. Allergy season, am I right? Okay. And then the last one is that the limit as x goes to 0 of cosine x minus 1 over x equals 0. Okay, so these are like the 3 things that you would need to know. They're at the top of the page in the limits packet, and they're 3 formulas that you have to just have these memorized. Now notice all of these are limits as x goes to 0. So if you see a limit sine x over x, but x approaches 1 or pi over 2 or something different, then just plug it in, right? So this property, you only need these if x is approaching 0. Okay, so we're just going to do like lots of examples to try to cover all the different fun things that you might possibly encounter. So example 1. And feel free to ask questions as or if you have them. You can put that on my desk. So the first one is the limit as x goes to 0 of sine 4x over x. So that uses that middle property, right? So what would the answer be? 4, that's it. It's easy enough. Okay, example 2. The limit as x goes to 0 of 7 sine x over x. So this one has the number in front, but if you think back to when we learned properties of limits on block day, there is the constant multiple rule where if you have a number like 7 times a function, we would just have to do 7 times that limit. So the limit for sine x over x is 1, so we would just do 7 over 1 and get 7. So it turns out it doesn't matter if the 4 is here before the x, or the constant, or if it's in front of the whole thing, that's just going to be your answer. So whether it's in front of the whole thing or in front of the x, that constant ends up being your answer for your limit. Okay? Alrighty, example 3. Now we're going to start having more fun. The limit as x goes to 0 of the sine of 2x times cosine x over x. So this is kind of a combo of things. So what we want to do is identify in each function where the property is that we could use and then kind of separate that out from the rest of the problem. So like here you see there's like sine 2x over x, right? So what we want to do is we want to separate that part from the cosine. So I'm going to rewrite this using our limit properties. as the limit as x goes to 0 of sine 2x over x times the limit as x goes to 0 of cosine x. So I'm just splitting those things apart. So they were together in the limit, sine 2x over x times cosine, and now I've split them apart. You don't need to put both of them over x because you're multiplying, not adding. Right? So if it was plus, then they would both have to be over the x. But since it's times, only one of them should be over x. Okay. So the limit as x goes to 0 of sine 2x over x will be what? 2, just using this middle property. And then for cosine x as x approaches 0, that's not one of our properties. But why don't we just plug in the 0 for x? So we have 2 times the cosine of 0. This is where a little bit of unit circle knowledge will be necessary. So remember, on the unit circle, here's 0. The point there is 1, 0. So what's the cosine at 0? 1. Remember, cosine is x. Okay, so that means we have 2 times 1, or 2, as our answer. So yeah, unit circle, that's something that we need to still know. And you need to know for the final too, so never hurts to, review that. So here are our properties. I just wanted to separate that. Okay, example 4. I want to do the limit as x approaches pi of 1 minus cosine 3x over x. Okay, so this one is sort of similar to that third property, but it's not exactly the same, and x does not approach 0. X is approaching pi. So if x isn't approaching 0, let's just try to plug it in. So I have 1 minus cosine 3 pi over pi, right? Okay, once again, unit circle. Yes, so let's see, 0 is here, pi is here, so that's pi. Then we come back around here, that's 2 pi. Then we come back around to over here for 3 pi. Okay, so 3 pi is over on the left side, right? Remember this? And the point there is negative 1, 0. So cosine is negative 1. So I have 1 minus negative 1 over pi. What's 1 minus negative 1? 2. Yeah, so 2 over pi is our answer. Yeah, they're used to hearing, when I make these videos, usually it's my children that are making noise in the background, but that's you guys. You're okay. It's okay to talk and ask questions. Okay. All right. Whoops, wrong way. Sorry, trying to straighten this up. Okay, so let's go to our next example. Let's straighten this out. Okay, example 5. We're going to do, like I said, several of these. How about the limit as x goes to 0 of sine 8x over 8x? So wouldn't that be the same thing as 1/8 times the limit as x goes to 0 of sine 8x over x? Because multiplying this fraction by an 1/8 will put an 8 on the bottom. So I can just take the 1/8 out because of the constant multiple property of limits. And then to do the sine of 8x over x, that is the second property we wrote down today, so that would just be 8. So basically we end up with just 1/8 times 8, which is just 1. Which is probably what you would have just maybe assumed, that you should do 8 over 8. But yes, you can do that and you will get the right answer. So I'm being like more thorough than maybe you would need to be, but just to show why we can do, the things that we're doing. Okay, example 6. How about the limit as x goes to 0 of x over sine 3x? So I have it upside down. The property is for sine kx over x. This one I have x over sine kx. So I could flip that, I guess. But if I wanted to flip that, I'd have to do like 1 over that would flip it. Does that make sense? Like, there's other ways you can do this, but this is one way. So it would just be 1/3. And you might have already sort of assumed or guessed that because this 3 was in the denominator to begin with, that it would be 1/3. But it does work out that if you make it 1 over and flip it, then it would have to be 1 over 3 because the property is, for this thing on the bottom, the limit would equal 3. And I have the 1 on the top. Okay, I think we're going to do like 2 more. And then we'll look in the packet and see if there's any in the packet that we need to do. Okay, example 7 is the limit as x goes to 0 of the square root of x plus 3 times sine x over x. So once again, this is kind of a combo of 2 things, right? We have the square root of x plus 3, and then we have the sine x over x. They're just multiplied together. So I'm going to split those apart. Limit as x goes to 0. I'm going to take the square root of x plus 3 and then multiply by the limit as x goes to 0 of sine x over x. So see how I did that? Remember, since they're multiplied together, that x in the denominator only needs to go with one of those 2 things. You don't put both of them over x, just put one of them over x. Okay, so for this first one, I could just plug a 0 in for x, right, and get square root of 3. So I have square root of 3 times, for the second one, the property is that the limit as x goes to 0 of sine x over x is 1. So I just get radical 3 times 1, or radical 3. Sweet.
So what do you do if there's a sign on the bottom?
Yes. We'll do that in a minute. Okay, example 8. Is that a good answer to your question? Yes. I hear your question. Okay. Limit as x goes to 0 of 2x plus sine 3x all over x. So this time they're added together. I have 2 different things added instead of multiplied. So when I split these apart, I do have to put both of them over x. So I have to do 2x over x plus the limit as x goes to 0 of sine 3x over x. Okay, so I'm splitting these apart to isolate the one that looks like a formula. So the sine 3x over x. So for sine 2x over x, won't those x's cancel out? So then the limit would just be 2. That's literally all I have left. So I have 2 plus, and for the limit of sine 3x over x, the property says that would just be 3. 2 plus 3 is 5. Okay. So your homework is going to be the next 2 pages. So pages, where are we on? Pages 9 and 10? Okay, so for pages 9 and 10, let's go ahead and go there, and maybe we'll do a few of those problems together. Do you have a request, number 2?
Number 2 and number 5,
just to see what to do. Sure. Okay, let's look at number 2. Number 1's pretty easy. So number 2 is the limit as x goes to 0 of sine x over 2x squared minus x. So definitely more complicated. But the rest of them aren't all like that. Okay. So can we factor the bottom of that? We can. So on the bottom, I'm going to pull out an x, and I'm left with 2 minus x. So look what I see now. Sine x over, thank you, 2x minus 1. What am I thinking? Right? Okay. Anyways, so we see the sine x over x, right? That's a property. So let's pull that apart. So we have the limit as x goes to 0 of sine x over x. And then times, what I have left is the 1 over 2x minus 1. So I'm splitting those apart. This time I kept them in behind the same limit. You can put them into separate limits. The principle is the same. So for this first one, the sine x over x, the limit as x goes to 0, that's 1, right? So I have 1 times, for the second fraction, just plug in a 0 for x, which is negative 1. Right, if I plug in a 0 here for x, I would just have 1 over negative 1, which is negative 1. 1 times negative 1, negative 1. The first one, because the property is the limit as x approaches 0 of sine x over x is 1. So that was for this first part. Okay, let's look at number 5. It's not hard, but it's one I didn't do an example exactly like. Once you see what to do, you'll be like, oh, cool. Yes. So for number 3, it's kind of like the last example I did. You'll split it apart as x over x plus sine x over x. All right, sweet. Is 1, but x over x, when you reduce it, is 1. So you just do 1 plus 1 and get 2. No. No, Chansong. Okay. So we have 3 sine 4x over sine 3x. So here's all you have to do here. This 3 in front is like a constant multiple. And then for the sine 4x over sine 3x, it ends up, that limit, you can just, it's just 4/3.
So it's literally 4.
Yep, so it's literally 4. So yeah, so for like, so if you have the limit as x approaches 0 of, let's say, sine kx over sine mx, the limit would be k over m. All right, how do we do number 4? Anybody have an idea?
Split them up.
Split it up. So sine squared x is sine times sine. So make that sine x times sine x over x, like that. You see what I mean? So what's the sine of 0? Nope.
Wait, how did you get the third x
On what?
on 4?
So sine squared x, like anytime you see sine squared x, that's the same thing as sine x squared. It's just a different way of writing it.
And also 2 sin x.
No. Yeah. That doesn't work with sine. That only works with logs. Okay. So sine squared x, it's just like a notational thing that they put the sign here, but it's really the whole thing is squared. So that's the same thing as sine x times sine x. Okay. So the sine of 0 is 0, and then the limit for sine x over x we know is 1. So I have 0 times 1, which is 0. And it's okay. You can get 0 as an answer.
Can you do 6?
Yeah. Why don't y'all skip number 6 for now?
You want to talk it out?
Sure.
You put 1 over the negative 1 times cosine minus 1.
Yeah. Yeah, something like that.
Yeah, but
Okay, let's look at one more. Let's look at number 11 together, and then I'll turn you loose. So it's a limit as x goes to 0 of cosine x minus cosine squared x over x. So what do you think we should do? What? We could split it up, or let's factor out a cosine on the top, because the property I want to use is the one with cosine, which says the limit as x goes to 0 of cosine x minus 1 over x equals 0. So I want it to look like this, cosine x minus 1 over x. So when I factor out, yeah, first I'm just going to factor out cosine. I'm left with 1 minus cosine x all over x. But notice that numerator is flipped. Instead of being cosine x minus 1, it's 1 minus cosine x. So when I split this up, so I have cosine x times the limit as x approaches 0. If I want to flip that around and make it cosine x minus 1, then all I would have to do is like take a negative out, right? So if anytime you have something that's backwards of what you want it to be, if you want to flip it around, just pull a negative out. And I'm going to choose to put the x underneath the cosine x minus 1 because that matches the property right here. So I get, well, we're going to get 0 because 0 times anything is 0. But the limit as x approaches 0 of cosine, well, cosine of 0 is 1 times, and then I have negative cosine x minus 1 over x. That limit is 0.
Negative 0.
Negative 0 is not a thing. Third hour. Are you listening? Okay, so we get 0. It's an inside joke. Some of them are obsessed with negative 0. Okay, so we get 0.
There's definitely a rule. Think about it. Any number can be negative, so why not 0?
Because 0 is neither positive nor negative. 0 is just 0.
But it still has a value. The value of 0.
It has no value.
No, 0 is not a number, it's a lack of a number.
Ooh, okay. There is no negative 0.
That's right. There is no negative 0. Have fun working on your homework. Bye.